Okay, in this video we will continue the beginner's guide to SDL2 in C++. This is the 6th video. So if you're joining this video, you want to go to github.com, Programming Rainbow, the beginner's guide to SDL2 in CPP. You want to clone that repository, and inside the directory you can grab the code that we finished off with. It'll be in the folder for video number 5. So if you go to video number 5 here, and you grab the main.cpp and copy it into the source folder, you will be right where we are right now for this video. So this is the 6th video. What we're going to do two things in this video. We're going to move the text around the screen and let it bounce off the walls, the text that we created from video number 5. And in this video, we will also load a window icon for people who are using floating window managers or operating systems that show Windows icon. And at the end of the video, I will load a floating window manager to be able to show you that window icon. I'll do it right before we end the video because I do have to reboot after I show you that. Okay, so let's get started. So like they said, the first thing that we're going to do is just move the text around the screen. So let's look at where we left off with the code. Okay, we will compile the code in the source folder, and we can run it. Okay, so we have, oh, sorry, this is not the correct. Let me just close this. I was updating the GitHub page with the what code changes kind of happened from the videos. So I'm going to copy the code from video 5 to the source folder. That's my fault. I should have already done that. Okay, yeah, that looks good. Now we will compile it. Okay, so we have the SDL in the TrueType font using the Free Sans Bold TTF that we loaded. We have the great text up here as our title. So in this video, we're going to be moving this around the screen, and then we will also load an icon and set that as the window icon. Okay, and we can still change the color of the background. I didn't show it, but we can still do it. So right away, let's change the title before we forget. We'll call this Moving Text and Icon. That will be the new title. Okay, and so right now we have this text that we've created. Where are we at? Okay, so we have a rect for it. What we want to do is we want to be able to move it around. So what we really need is a way to update the X position and the Y position. And since I want this to actually detect whether I've run into the wall or not, and then change directions, I'm going to have two different velocities. I'm going to have an X velocity, so it can change. It'll be held in a variable. I'm going to have a Y velocity, and I'm going to be flipping those from positive to negative. So I'm going to have a third constant variable called velocity. So I'm going to have a constant called velocity that I'm not going to change, and then I'm going to use that to set whether it should be positive or negative on the other velocity. So it'll make sense in a minute, but we're going to make 3 variables right now. They're just ints. But as I said, the first one I'm going to create it as a constant. I didn't do it in my notes as a constant, but I am going to do it. So it's going to be const int, and this will be text val. Okay, so that's going to be we just want a velocity that we can hold on to, that it's never going to change. And then we want our X and Y velocities that will be variables that we will change. So that'll be int text xval. So I'm using this name text because it's kind of grouped up, even though it's just a unique name text with an underscore. I'm just using that prefix text because it does belong to my idea of what's happening with the text, even though we're in the same class. So we have text xval and int text yval. So that's X velocity and Y velocity. So in our constructor initialization list right here, This one happens right after the rectangle. So I'm going to put them in, I'm going to initialize them right here. And I think I'll just put them down here since I have more room here. When I save it, my LSP will automatically reorganize how the code is. So text vel is going to be 3. They're all going to be 3, to be honest. Xvel is also going to be 3. Text yvel is also 3. So we have the text velocity, we have the x velocity, and the y velocity, and they're all initialized to 3. Okay. Yeah, see, it moved it around. That's fine. As long as it's correctly has its punctuation, it's going to be fine. So we need some way to update this every frame. And what I want to do is I want to move the x by x velocity every frame, and I want to move y by y velocity every frame. So it's set to 3, and we're about 60 frames a second. So that's going to move at about the speed of about 180 pixels per second, which is it's a decent speed. It's not too fast. So what we need is we need some way to update this every frame. So we're going to make a new member function, and this one's going to be private because it's only going to be called inside of the class. So I'm going to put it right up here, and I'm going to call this void text, or maybe we'll just call it update text. That would be better. And that will be the name of that. I'm going to give it a space here because I'm going to group any functions here, any simple variables here, and the unique pointers are here. So it's just so I can, at a glance, when I'm looking for something, I can find what I'm looking for very easily. So I'm just mentally separating them out. So we have this member function that's update, and we will create it. So under load media, right down here, we can make our new method or member function, however you want to call it. And this is update text. Okay, and before I fill this in, I want to make sure that this is called. I don't want to forget that I've called it. So I'm just going to go down here, and where I want this to happen is in my game loop, I always want to check for any events that have happened. Once I've checked for any events, I want to update any game state, and then I want to draw. So right here between checking the events and drawing, I want to update any game state changes, and that's going to happen right here. So I'm going to call this update text. So I just want to make sure that I remember to put it there before I go too far. So the first thing that we can do here is we can just, like I said, update the x and the y by the x velocity and y velocity. So I'm going to take this, and then it's text rect dot x, and I'm going to say plus equal. So I'm incrementing it by whatever this text x velocity is. Okay, and I'm going to do the same to the y. So this text rect y plus equals this, and we'll do the y one, text y velocity. Okay, so we're just changing the rectangle, and I'm changing the x and the y, and these are 3. So every frame, this x is going to be 0, 3, 6, 9, 12, and the same with the y, because they're both set to 3 right now. And this is being called right here, and then what's being drawn right here with that rect. So we should see the text moving diagonally from the top left-hand corner to the bottom right-hand corner, and then off the screen because we're not stopping it. So let's check that. Okay, there we go. And it's going to go right off the screen and just keep on going. Okay, so now what we need to do is look for the collision, and we'll change the velocity when that collision happens. So I'm going to do an if statement, and I'm just going to check So if I want to check the right side, what I need to do is I need to check X, but I also need to add the width to it. And I need to check that against the width of the whole window, which I already have saved as a const expr up here. So I'm going to check it against that. So right here. Yeah. Okay, so we'll say if, what we'll do is we'll say this text rect dot x plus this, we're going to say text rect dot width, or it's dot w, but that's for width. If this is bigger than the width of the screen, which is this width, then we want to do something. So imagine, let me disable this for a minute here. Okay, just so I can show you what I'm talking about. Okay, so imagine this, this is my SDL right now. The X and the Y for this SDL is actually 0, 0. It's this very top hand corner. Not for the screen. Of course, the screen is the same, but just for the image, the SDL image, the X and Y right now is set to 0, so in the top hand corner. So X is the left side of my image. Now, if I take X and I add the width, which is held in the rect.w, which is the width of this, I'm going to get the right-hand side. I'm saying X plus width is this side. So if this L right here, the side of the L, moves beyond width of my screen, I know I'm going off the screen. So this is 0, over here is 800, right? Or width. Width is 800. So if this is moving this way and this L penetrates 800, I want to change the direction. So that's what I'm doing here. I have X plus width. And over here, Y is the top, and Y plus height is the bottom. So if I want the bottom, I do Y plus height. If I want the top, I just say Y. If I want the left, I just say X. And if I want the right, I say X plus W. And this is 0, and this is width, and this is 0 up here, and this is height down here. So just to visually see what I'm talking about here. So let's uncomment these. Okay. So yeah, so we've penetrated the side. What should we do? So why don't we just change the direction that we're moving? So we're just going to change the, I'm not even going to move the image or reset the image or stop it from being off the screen. I'm not going to do any of those things. I'm going to keep it really simple. And all I'm going to do is going to say, since we've been updating by X velocity, let's make X velocity a negative number now. I don't want to change the sign of it, because if I'm past the screen, it could flip-flop back and forth every time if there's another frame and it's still past the screen, it could just keep flipping back and forth and then just never move. What I want to happen is just say, hey, if you're too far to the right, you should be moving to the left. So it's going to be this. We're changing the text X velocity. So this X velocity, and we're setting this now to the negative version of text. Oh, sorry. This text vel, not xvel, text vel. So remember, this is the constant. We set one constant, and the other, the xvel and the yvel, are variables. That's where this comes in. This one is always holding our 3, and this is going to be 3 or negative 3, depending on what we do. This is always holding our 3. Okay, so we can do this very same thing for the y. So I'm just going to copy this right here. Oh, actually, let's just check that the x is doing this. I'm going to comment out the y, but I'm also going to put the other version of this. We can say, we could put it above to make it even easier. We could say, if this text rect.x is less than 0, if it's less than 0, and I'm going to remove one of these. Well, I'm not going to remove it. I'm going to put it here. And I'm going to say else if. So we don't need to check it twice. If this has already happened, we don't need to check the second one. So basically, if it's moving this way, if we're checking the left side and it's moving to the left, and we're checking X and X hits 0, we want to make sure we change it to the right. So we're doing the exact same as down here, except we're not doing the negative version. This text rect dot X, and we're going to just set it equal to, oh, sorry, not X. It's xvel. This is going to, we're going to set it, xvel, to the positive version of this velocity, text velocity. Okay, so it's the exact same thing as this. It's just the opposite version. We're just checking X, not X in width. And we're checking it if it's smaller than 0. And if it is, that means this was already a negative number because we're moving to the left and we want it to move to the right now. So we've set it to the positive. So if this is true, we're doing this. If this is false, we're going to check this one. And if this if is true, we're doing that. Otherwise, we're going past it. So this is just the X happening. So we're just going to update our X every time. And this is going to flip our X velocity from positive to negative each time we bounce off the screen. And that should just go back and forth. So let's try that. Okay, so hopefully we'll bounce off the right side. There we go. And then we should bounce off the left side. Okay, so we're not doing anything fancy. We could go in here and just say times -1 to flip the sign, but imagine if you went too far in here and you did that, it would try to change this direction, but the next frame it would already be in here, and then it would try to change back, and it would end up going back and forth and not doing anything. So this one, I'm doing the simplest. I'm not trying to be fancy about it. I'm just saying you need to go the other way. If you're too far this way, no matter what, you need to go. It doesn't matter if you're for 5 frames too far this way, you're still going the other direction. Okay, so we're going to do the exact same thing for the Y. So I'm just going to uncomment this, and I'm going to copy this and set the same thing for the Y. And you could put these in their own if statements or if else. If else is just slightly more efficient because in the chance that this one is triggered, it doesn't check this one, but it's not vastly different. So it doesn't really matter if you put them in their own if statements. But the logic of all of this is the same. So all these Y's are going to change, all these X's are changing to Y's, and then the width is changing to the height. And the W changes to H, and the width changes to height. And all the logic and the sign of it is all the exact same. Okay, hopefully that's all correct. Let's check it out. I did not recompile it. Okay, now we should be bouncing off the bottom and the right, yep. And then bounce off the top and the left. Okay, that's perfect. And we can still change color. And we have our moving text and icon set up there. So it's all great. So let's switch gears now since that's working. That's pretty simple. So we're going to do one more simple thing. It's going to be not too much, but what we're going to do is we're going to load an image as a surface, not as the texture. We only need the surface version because we're not going to display it on the screen. We're going to load it as a surface, and then we're going to set it as the window icon. And we'll actually be able to use it in the next video. When we need that texture, we can convert that surface to a texture. But in this video, we're going to load it to a surface and then set it. And what we're doing here is using this image right here. This is CPP logo. It's the C++ logo. And we're going to set that as our window icon. Okay, so I'm going to show you a couple functions here. To load an image, we've already loaded up the image module, so that's already good to go. And we have used image load texture before to load an image directly as a texture. But again, I said in this one, we don't need a texture, we just need a surface. Because what we're targeting is this one right here, SDL set window icon. This one takes in the window pointer and then takes in a surface. Okay, and it's returning void. It's not even going to tell us if it fails or not. So it's just a simple function call, but we do need a surface. So we're going to, instead of using image load texture, we're just using image load, which is going to give us a surface. So we don't even need a render here. We just need the file that we're going to load. So I am going to create a new pointer for a surface. We've already seen this before, so this is nothing new happening here. We already have a surface that's holding the font surface. Where is it? Right here, this text surf. Right here. I'm going to copy this one. Now I'm going to call this one icon surface because, like I said, we'll be able to use this as well in the next video. We'll be able to use it twice. So I know it is the icon surface, but I'm also going to use it as the sprite. So, well, we can just call it icon surface. It matters not. So yeah, I will call it icon surface. Icon surface. So this is a unique pointer and the type is SDL surface. And the declare type to get the type for the deleter is SDL free surface. That is all correct. That's the type of thing we need. So I'm going to go, let's see, not sure if this is a bit weird for me because I want to do this. I want to do this in the initialize is where I want to do this because but I am loading media. So I am going to do it here in the initializer because in my head I'm thinking of this as initializing the window and getting it up and running, but we are actually loading an image. But for this, we would normally load this and release this right away if I was in just C, but since I'm using this unique pointer, I'm just going to use it twice and for the next, I'm going to use it for the next video too. So I'm going to do it here in this initialization. And what I'm going to do is I'm going to use that function we've already seen, the image load. So yeah, and we are going to check it the same way. So this is the exact same thing. I'm resetting a unique pointer. So this, and this will be icon surf dot reset. And the function that we're doing is image load. And all we need for this is the relative path to the image, and that's the CPP logo. So it's images, and then capital CPP minus logo dot PNG. And that's going to load our surface. And now we need to check to make sure that this surface is actually loaded. So I'm just going to grab one of these up here, these error messages. For this one, we need to check that it is the icon surface. Icon surf, and we do want to error loading surface. And I want to get this for the image. This is an image error. So error loading surface, image get error, and we're returning the runtime. So that should load our surface that we need. I'm just going to check to make sure that that is all good so far. We haven't got an error message. Okay, we did something wrong. And very bad. Okay, I just want to get up to the top, the first thing that we've done here. You know what I think we've done is maybe no. I think we use the same name. Maybe I forgot to put a semicolon. Let's just check. We know it's up here at the unique pointer. Oh yeah, it must be something going on here because it's not happy with any of this. SDL surface, yeah, that's what it is. And declare type free surface icon. Okay. And there is a semicolon there. Oh, I know what I did. I'm looking at it here, and what it's saying is I haven't initialized it down in the constructor initialization list. So I needed to initialize this to null down here. That's what's happening. So yeah, this is complaining about, yeah. Let's see if I can just pull it up as a floating window. It says constructor for game must explicitly initialize the member icon surf, which does not have a default constructor. So yeah. Oops. So all I need to do is, that was the last one we put in, so I just need to come over here right before. This is the actual constructor here. This is the initializer list. So before that constructor part, I need to put in here, and this is icon surf, and this will be a null pointer. And we need to put in the SDL free surface. That should be good. Okay. So there, it's good. Hopefully that was the end of that error. Yep, that looks good. Okay, everything's still working. That's great. Now we haven't actually set it yet. So we've loaded a surface, and we can check to make sure we really loaded that surface by misspelling it. So it's in game initialize. Where is that? Game init. So right here, if we spell this wrong, we should get an error. A runtime error. There's our runtime error, so we do know that it is loading that surface. Okay, so we have one more function here. Let's check it out. And this is the SDL set window icon. And we can't capture whether it fails or not, so we're not even going to test if it fails. But it's just this function call. I'm just going to copy that. And then we're taking in the window pointer, not the renderer pointer, but the window pointer. And we're taking in the surface that the icon surface, the pointer to an SDL surface. Okay, so right below here, if this is all worked out, we can go down here and we can set that. So this window, and we need to unwrap that smart pointer, and then the same for the surface. Icon surface, get, okay. So we're going to just check this real quick. Okay, no errors. So now let's show you what the surface let's show you what the window icon that we loaded looks like. It should be a CPP logo. So what I'm going to do now is I'm going to load up a floating window manager called KD Plasma 6, and we will check it out. So I need Zephyr. That's the nested that creates a nested X Windows session. Okay. And I'm just going to open Alacrity. That's just the terminal I've been using. So this is what the icon looks like for Alacrity right here, this A, and you see it down here as well. This is the icon. So we're going to be looking for that, but it should be a C++ logo instead. So I'm going to go right into what I was already in before. And we're in the exact same, this is the exact same code base. Everything is the exact same. Nothing has changed. I'm just in a different window manager. If I run demo, I'm running that exact same binary that we were already running. But this time, we should see a Windows icon. Okay, there's our icon right there, C++. If we go down here, we can see it as well. That is the image that we loaded for the icon. So it is setting the icon, and we have this moving text and icon as our title message. So that is everything that we have been doing to this point. Okay, so should have walked through it. So I kind of want to walk through the code, but the problem is, well, can I, hold on, maybe I can shift this to another screen. There we go. There we go. There we go. Okay, I just want to go through the code real quick again, what we did. So we haven't added anything new right up here. We're not doing anything new. We did add a constant for text velocity and then two variables that we can change. The text x velocity and text y velocity. So those two are variables that we can change. And we've initialized all of them to 3 in our initialization list. And we've also created a new member function, but this one's private. So we have this, what we're doing is we're working with the text rect, the X and the Y, and we're updating the X member by the text X velocity. And we're updating the Y member by the text Y velocity. And then we're checking for the bounds. So if we're moving left, we're checking the X if it's smaller than 0. If it ever becomes smaller than 0, we are just setting the velocity to the positive version of our velocity. So if it was going this way, now it's going this way. If we check the other side, over here we're checking X plus the width and seeing if it's larger than our width of our screen. And if that happens, we're setting the X velocity to the negative version. Make it go from the right to the left. And we're doing the exact same thing with the Y. The math is all the exact same. Everything's the same. We're just changing all the X's to Y's and the H's to, or the W's to H's and the widths to height, and it's the exact same. And then we're making sure that we call that. We're checking all the events that we're checking first, and then we're updating state, and then we are drawing everything. So that deals with the updating. And then the last thing that we did was we created a new unique pointer to an icon surface, and we have to initialize that pointer. So we're doing that there. We're initializing it to null. And then we're in the game initialize section, and we have created the window, the render. And so what we're doing here is we are resetting that surface, the icon surface smart pointer, and we're just using the image load to load the C++ logo. And then we're checking to make sure that it really got loaded. And then if it was loaded, we are using the SDL set window icon, using the window pointer and the pointer to that surface to set it. And there is no check to see if this failed or not. Okay, so that's everything. I hope you enjoyed that. Thanks for watching. Bye.